Look closely at the circular designs on this traditional woven mat. If you understand how the rings expand outward, you can predict exactly how much material you need for the next row without having to count every single piece. You see the same logic at the market. By observing how these pineapples are stacked, you can calculate the amount of fruit in the bottom rows based entirely on the shape of the pile. In mathematics, we call this a sequence. A sequence is simply an ordered list of numbers that follows a specific, repeatable rule. To find the rules behind any sequence, we have to separate two ideas, the position and the term. Think of a commuter taxi. The position, which mathematicians call n, is the seat number. The term is the actual person sitting in that seat. Seat number 1 might hold a passenger weighing 80 kilograms. The 80-kilogram passenger is the term. The first seat is the position. Separating the spot a number holds from its actual value allows us to define the relationship mathematically, which is the only way to calculate any term in the set. Let's visualize this process using a double number machine. This machine takes an input position, n, applies a mathematical rule, and generates our output term. For this specific machine, our rule is to multiply the input by 3 and then subtract 2. If we drop our first position, the number 1, into the funnel, it gets multiplied by 3, which gives us 3. Then we subtract 2. The output that drops into the tray is 1, so our first term is 1. Let's speed it up for the next few positions. Input 2 becomes 4, input 3 becomes 7, and input 4 becomes 10. Our generated sequence reads 1, 4, 7, 10. If you only see the numbers 2 and 4, the rule could be add 2 or multiply by 2. You need to see the third number to know if the next is 6 or 8. This is why you must always test your rule against at least 3 terms to ensure your predictions are accurate. Generating numbers is straightforward when you already know the rule. But what if we only have the output? Look at this sequence on the board. 5, 8, 11, 14. Our goal is to reverse engineer these numbers to find the algebraic rule. Step 1 is finding the gap. Notice how these numbers jump by exactly 3 each time. Because the gap is a constant positive 3, we know our algebraic formula must start with 3 multiplied by n, or 3n. Step 2 is testing that base rule on the first position. If we plug n equals 1 into 3n, we get 3. But look at our sequence. The actual first term is 5. To fix this, we calculate the adjustment. How do we get from our test result of 3 to the actual term of 5? We have to add 2. That makes our verified rule 3n plus 2. Now pause the video and apply this 3-step method to find a formula for this sequence. 7, 10, 13, 16. Let's check your math. The gap is positive 3, giving us 3n. Testing position 1 gives us 3, but we need 7. To close that gap, we adjust by adding 4. Your final rule should be 3n plus 4. Translating a sequence into an nth-term formula allows us to discover an algebraic rule that applies to every possible position, no matter how high the numbers get. Let's put that formula to work. Imagine a carpenter in Ndiba making wooden chairs. On Monday, he makes 4 chairs. As his team gets faster, he makes 7 chairs on Tuesday and 10 on Wednesday. We can translate his daily production into the sequence 4, 7, 10. Using our 3-step method, we determine the general rule for his production is 3n plus 1. If we want to know how many chairs he will build on the 15th day, we simply replace the position n with 15. 3 times 15 is 45, plus 1 equals 46 chairs. We can also work backward. If we know he produced exactly 31 chairs on a specific day, we set our formula, 3n plus 1, equal to 31. Subtract 1 from both sides to get 3n equals 30. Divide by 3, and we find that n equals 10. He built those 31 chairs on the 10th day. Here is your final summary card. It covers the core vocabulary, the 3-step rule for finding an algebraic formula, and the rules for special patterns like square numbers. Take a screenshot for your notes. Understanding how to generate and apply these formulas turns a list of numbers into a predictive tool for the real world. You can accurately forecast requirements for building materials, inventory, or business growth before the work even begins.